Okay, guys. So as we are looking at average rate of change, which is really what a derivative is, I want to show you something to see if this would make sense. All right. So the question is, does the ball fall at a constant rate? What do you guys think? It's kind of hard to tell in real time, right? Say, what do you think?
I think it's faster.
You think it gets faster? Okay. So here's what we're going to look at. We're going to get something that will let us kind of slow down and look at this thing in smaller pieces. If I ask you to find the average rate of change of something, then if we're talking about something that's traveling a distance, it's going to be the change in distance over the change in time, right? So, for example, if you guys were to calculate what your average speed is when you're driving somewhere, all right, unless you have been on the highway the entire time with cruise control set, over the period of an hour, you could calculate what your average rate of speed is, but especially if you're traveling somewhere where you've got stop signs or stoplights, does your speed actually change throughout that trip? Absolutely. Now, I can calculate the average if I take the total distance that I travel over that hour and divide by the change in time. But we talked about the idea that if we wanted to, in the real world, most things are not always moving or changing at a constant rate. Sometimes they're moving faster than others. And so if we need to find the rate of change at a particular instant in time or a very small unit of time, we need to figure out a way to do that to be more efficient. Now, look at this thing, and what I want you to see is this is kind of slowing it down as far as it's giving you certain intervals when it's dropped a meter and the speed that it's traveling. So here's what I want you to look at again, because we saw it at the top. Wait for the animation to begin. Okay, I'm waiting. All right. So that's what it looks like if I'm just looking at it in real time. Now, let's see if we can get it to go. Come on. All right, so this is going to show how the ball actually speeds up. So there's the first. Notice the change. Okay, so it's kind of taking little snapshots, and you can tell when it first falls, it's not moving as fast as it is at the end. Now, why do you think that is? What is there in the real world that's going to make it change? Gravity. Gravity's pulling on it, right? And so as it's moving, the force of gravity is going to cause it to accelerate and start to go faster, okay? Think about a car that's driving. If you took off at 60 miles an hour, what would that feel like? Assuming it was even possible. I mean, you would, you'd be thrown back in the seat. You accelerate to get to 60 miles an hour, if that's, say, the speed you want to travel at. So your speed is changing, and that would mean that if I want to see what was my average rate of change over the first 100 feet that I travel, I'm going to get a totally different value than if I calculate what was my average rate of speed over the first half mile that I travel. So I want you to get the idea that as things are in motion, you end up with some change in speed. Okay, now as it applies to what we're talking about, we said the other day, if you picture a curve and we were to pick any point on that curve, rate of change would be the change in y values over change of it in x, right? And so if I were to pick two different points on the curve, like here and here, if I drew a line connecting them, I'm able to find rate of change on something that's a line by calculating the what? The slope, okay? So I could pick any 2 points and I would be able to find the slope. Now, look at this. Let's say, this is gonna let me make it active. No, this one is not. Oh, let's see. We're gonna open that. Yeah, let's go here. Okay. So let's say what we do instead is we try to move these points a little bit closer together. So I'm going to move this green point in. Notice what's happening to my average velocity. The closer this green point moves to the brown point, what's this number doing? It's getting bigger, isn't it? And so the closer I get, the closer I'm getting to what would be an instantaneous rate of change, right? I mean, as long as I have 2 points, I can calculate a slope. So if I get these 2 points really close together, it's as if I'm able to figure out what the slope would be through a line that's passing through those 2 points, and it's almost going to be the same as if I were just at that 1 point, okay? Now, in theory, if I could find a way to squeeze those 2 points so close together that really it became 1 point and I get the slope there, I would know the instantaneous rate of change at that 1 point, okay? That's the idea behind derivatives and calculus, okay? So I wanted you to see that to kind of get a grasp on what it is we're trying to do here. And you could play with some other things. In fact, if you guys are kind of interested in this, let me know, because I could put this link on our resource page in the course, and like it explains how radar guns work. There's all kinds of cool things where you can see how this applies in the real world. Have you ever thought about, let me just explain this real quickly. Anybody ever gotten a ticket? Ah, okay, got a few honest people here. So my question is, this may not have happened to you, but have you ever been driving and maybe you see a police car or somebody warns you there's a police car coming up? So you slow down when you see the police car, he doesn't come out after you, speed back up to whatever speed you want, and then down the road another police car gets you, even though you weren't speeding when you passed the second one. Have you ever wondered how they can give you a ticket even though the first one didn't clock you speeding and the second one didn't clock you speeding, but yet they're going to give you a ticket and tell you you were speeding? How could they possibly defend that in court and that ticket be valid? Do you know? There you go. They're using calculus. They're using average rate of change. If they clocked you at a certain speed, let's say that you did the speed limit 70, and they clocked you at 60 when you went through the first point, and then maybe they clocked you at 70 when you went through the second point, but because they know the exact distance, let's say that that was 5 miles apart, okay? If the speed limit is 70, they can calculate how many minutes it should be to get from point 1 to point 2. If you get there faster than that, you had to have been exceeding the speed limit. Aha, didn't know that, did you? So there's a lot of applications in the real world. That may be some of the things, if you're interested. Like I said, I can put this link on there for resources. And let's see, I don't want to close all the tabs. I'll just minimize this. And we will now let me make sure. Okay, new share. Now we're doing that one. Okay, are we good? So, you guys got your notes out? Let's talk about derivatives a little bit. So, derivatives, average rate of change. And what we're going to look at is if I have some point, we're going to call it point A, kind of like we looked at on that curve. And I add some distance to it to get to another point, and we'll call that distance h, okay? Then, how would I calculate the rate of change? It's the same as slope. Couldn't I take the y value from this point, which would be my f of a plus h, and subtract the y value from the original point, that's my change in y, over this would be my change in x's, right? Because my x is at point A. My second point, the x value is a plus h. So I would take the second point minus the first point. Now, the cool thing is in the denominator, what happens if I simplify that? I just get h, right? Because the a plus h, when I subtract a from it, the a's are going to cancel. This is the basic formula for finding a derivative. But now here's a problem. Because there's a fraction and h is in the denominator, what is it that h can't equal? Because if I try to plug in directly, I can't have 0 in the denominator. This is why we need limits, okay? Because remember, what did h represent? The distance that we were moving away from the original point. And we said to get instantaneous rate of change, we want that distance to be what? Very small. In fact, we would like for it to end up being on top of the same point. That's why we would want that h to get as close as possible to 0. So guess what we'll end up doing? We'll take this formula we just figured out, and we're going to find the limit as h approaches 0. That's how you can calculate the derivative, or the rate of change that's instantaneous for any point on a function. So even if it's a curve, I can calculate it. Now, these are going to be the steps that we go through. It's called a 4-step process. We're going to get some sort of function. So they're going to tell us what f of x is equal to. We're going to need to find what f of x plus h is. I'm going to walk you through these steps because basically, remember, we need 2 points. So my first point would be x, comma, and then whatever f of x is. My next point is going to be that x plus h, because I got to add some sort of distance to x. And then I will find what f of x plus h is. After that, then I am going to set up this fraction. I'll take the difference in the y values over the difference in the x's, but the difference in the x's will always end up just being h, and then I'm going to find the limit of that as h approaches 0. So let's look at a few examples here. Okay. First thing it says is use the 4-step procedure to find, now here's some notation we need to get comfortable with. This is f, and it looks like an apostrophe after it. You know what you call that when you have an apostrophe after something in math? Prime. Very good. This is going to be f prime of x. Okay? And what that prime stands for is saying we're finding the derivative, or the rate of change. Okay? So the first thing we have to do is find what that formula would be to get rate of change, find the derivative. And here's the cool thing about it. If they give us some sort of function, like this one, when you calculate that f prime, when you get your rate of change formula, I could then pick any point on the line and find what the rate of change is. So it's like you do the process one time, and then you can get the slope anywhere. the rate of change anywhere, because now you've got a formula that lets you find it. Okay, now this one should be easy for us, because if I were to ask you what this would look like if we graphed it, what would you tell me this would be? That's a line. That's linear. You can find rate of change for a line already, because we said rate of change is slope. So before we even start this, do you know what the answer ought to be? What would the rate of change be on this particular function, since it's a line? What's the slope? 7. All right, so then they're giving us one that's easy, because that way we're starting off with something that we already know what we should end up with. Now, let me show you the 4 parts. All right, the first thing I'm going to want you to do is to identify what our 2 points are. So I already know that if I put in x, my y value is 7x minus 3. Agreed? Okay, because that's my function. So whatever value I put in for x, my y will be what happens when I plug x into this, 7x minus 3. Now, I've got to get the other point. And the other point is going to be x plus h, because I've got to add some distance to that point. And then I need to find what f of x plus h is. Remember, that's what it said. I was going to have to figure out what f of x plus h is. Now, the way I find it is I go back to the function, but instead of plugging in x, wherever x shows up, I'm going to plug in x plus h. All right? Does that make sense? Because this is telling me what I'm using for my independent variable. All right? Here, I'm plugging x in. That's going to show up as my variable. Over here, I'm going to put an x plus h wherever x was. So this is going to be 7 times, now in parentheses, I'll put x plus h, because that's what's going in for the x. And then I'll clean this guy up so I can see without the parentheses what this y value should be if my x is actually x plus h. Does that make sense? All right, so if I distribute, what's that going to give me? 7x plus 7h minus 3. Good. The 7 only distributes through the parentheses. And that's going to be my second ordered pair. So here's the first ordered pair. Here's the second ordered pair. Now, and you can decide if you want to do it in all the parts. They're saying part 2 is the step where you just find the numerator that belongs in the fraction. You want to see what f of x plus h minus f of x is. You're finding your difference in your y values. So if that's the case, I'll take my f of x plus h, which is 7x plus 7h minus 3, and I'm going to subtract what from it? What's the y value in the other ordered pair? 7x minus 3. Very good. Now, be very careful, though, because I'm subtracting this entire y. Do I need a parentheses? Oh, I do. If you leave it off, you will mess up. Okay? You're going to put your first, your f of x plus h y value in a parentheses. Put a minus sign, because it's got to be the difference in the y's. And then you'll put the original y value in a parentheses following that. Now, the reason this is listed as a separate step is because with that minus sign, do I have a little bit of cleanup I need to do here? I actually do. I'm going to have to do what with the minus sign? Distribute through this parentheses. So that's going to equal, and I don't need the parentheses around the first one. So that's just 7x plus 7h minus 3. What will I write now after I've distributed the minus 1? Minus 7x plus 3. Very good. Now, here's, yes, ma'am.
Why don't you need the parentheses?
Because there's not a sign in front of it or a number in front of it. So if there's a plus sign, I really don't have to have it. I wrote it there just to show this was the second y value, and then we subtracted the first y value from it. But whenever we start to combine terms, we really don't need the parentheses around the first one. There was nothing to distribute. But do I have terms I can combine now?
Yes.
Okay, now this is the important part. Pay attention here. When I combine like terms, do I have some things that cancel out?
Yes.
What cancels? 7x minus 7x cancels, and negative 3 plus 3 cancels. The only thing that remains is what? All right, now I'm going to say this and I'll remind you as we go through. If you do this correctly, guess what should be the only terms that remain in your numerator? Terms that have H in them, okay? Everything that doesn't have an H in it, after I've done the f of x plus h minus the f of x, when I clean it up, everything that didn't have an H in it ought to cancel out, okay? So if that doesn't happen, that's a clue you've messed up somewhere. Either you didn't calculate the f of x plus h correctly, or more than likely you made a mistake with the sign. You didn't distribute or something. So keep that in mind. Everything that doesn't have an h in it ought to cancel on this step. All right, so now we have a cleaned up numerator for our function that we're going to use to find the derivative. So part 3 is where we actually plug in the f of x plus h minus f of x over h. Because remember, in the denominator, if I take x plus h and then I subtract x, the x's are going to cancel. The only thing left would be the h. So that's going to give me 7h on top over, what's in the bottom? H. Okay? And the last step is I'm supposed to find the limit of that as h approaches 0. Now, do you see something else that can clean up? Exactly. If I have an h on top and an h on bottom, these are going to cancel. Here's why you should only have terms that have h's in the numerator, because as long as that's true, h is going to be a common factor. And if I factor out an h on top, it will cancel with the h on bottom, which is how I'm going to be able to solve for the limit. Okay? Which now gives us the limit as h approaches 0 of the number 7. Okay, we had some limit rules that we learned. Do you remember what the limit of a constant is? What would be the limit of 7 as h approaches 0? Remember, this function is like saying y equals 7. What would that be? It's a horizontal line, isn't it? And what's the y? Remember, limit is looking for the y value. What's the y value of every point on the line y equals 7? 7. That's because if it's a line, it has the same slope everywhere, right? It's a constant rate of change, and the rate of change is 7. We knew that's what we ought to get because rate of change is slope, and when it's linear, I've got it in y equals mx plus b form, so whatever's in front of the x should be my slope, and that's easy if it's linear. Okay, so it wouldn't matter which points I pick on the line, I can pick any point, the slope is going to be 7, the rate of change is going to be 7, and it's constant, it's not changing anywhere, right? Okay, so that sort of makes sense. Now, let me tell you something else as we work through here. You may find little shortcuts you feel like you can take where you don't necessarily feel like I've got to do step 1, step 2, step 3, step 4, separately. I will tell you as we look at some things, calculating this correctly is very, very important. So I would make sure I get this figured out somewhere, and I really think writing out these 2 points before you try to plug anywhere would be very important. You may find this step you don't think you need because you may be able to do all of it right here, and I'm fine with that. But what I want you to understand is when you start to solve this thing, you've got to have the word limit appear. and you're finding the limit as h approaches 0, and you don't lose the limit as h approaches 0 until you would actually be plugging h in for something. In this case, there wasn't an h anywhere, so when we evaluated this, we used that rule that the limit of a constant is the constant, okay? In a little bit, what you're going to see is sometimes we still have h's left if we started with something that wasn't linear. So let's look at another example, because if I look at this thing, do you already know what the graph of this would look like? What do you think? It's quadratic. This is not going to be a line, it's a parabola, right? And that means there's curves, and it's got a changing slope. It's a different rate of change depending on where you are on this curve. So here's what I want you to see. I know my point that I'm going to start with, whatever I use for x, my y value is going to be negative 3x squared plus 5x minus 6, sorry. My other point that I need to find is going to be x plus h, and then how do I find the y value for that? What do I need to find? What did we do up here to find this part? Say again. Good, Victoria. You got to substitute x plus h in for x and see what f of x plus h is. So I'm going to do that right here. That means I'm going to have negative 3 times, and then I'll have x plus h in parentheses squared, plus 5 times x plus h minus 6. Okay, now there's a little bit to clean up there. This one is not as neat and tidy because we have some exponents and we have more terms. Tell me how we would need to go about expanding this so we don't have parentheses anymore. What would be the next thing that needs to happen? All right, I got an exponent. Remember, think order of operations. I don't have anything inside of parentheses that can be simplified because they're not like terms, but the next thing in PEMDAS would be E for exponents, and there is an exponent. What's being squared? The x plus h. Now, carefully see if you can tell me what happens if you square x plus h. What do you get? And please don't tell me x squared plus h squared. You got to use FOIL. It's x plus h times x plus h. Now, in case it's been a little while, let me just show you. If you want to, if you're more of a visual person and FOIL is kind of not maybe your thing, I've got x plus h, that's 2 terms times 2 terms. X plus h times x plus h. So if I make a box that's 2 rows, 2 columns, I can put x plus h at the top of each column. I can put x plus h beside the rows. When I multiply these together, the answer goes in the box where they intersect. What is x times x? X squared. What is an x times an h? Doesn't matter the order I write them in. I can put xh or I can put hx. I got another one of those guys right here. And then h times h is h squared. Now, if I have like terms, they're going to show up on the diagonal. Do these guys match? Yes, they do. So here's what I know. This becomes negative 3 times, if I pull this out of the box, I've got x squared plus what? I've got 2 of these h times x terms. So plus 2hx, and then I have a plus h squared. Now this I can just distribute because I didn't have an exponent on it. So that's going to be what? Plus 5h minus 6 on the end. And we still haven't finished because now we have to distribute what? We got to distribute negative 3 through all of this. So that's going to be negative 3x squared minus 3 times positive 2hx is what? Minus 6hx. And then what's negative 3 times positive h squared? Minus 3h squared. Good. Plus 5x plus 5h minus 6. All right. Let's see if the magic happens. What do we have that we can combine? Anything? Or are these all different?
Yeah.
I think they're all different, aren't they? I don't see any like terms. We went from having 3 terms in the original first term for the y value to 1, 2, 3, 4, 5, 6 terms. Okay? That's all right. And that's why I'm saying you got to have some space to expand this out, because you're not going to be able to do all of this in your head. Or at least I can't. Plus 5h minus 6. Wow, that's a heck of an ordered pair, isn't it? All right, but at least we now have 2 points we can use, the original and then this imaginary point where we add some distance h to it. Okay, you remember what we do now? What are we going to need to find? There you go. You can either go straight to the formula, the whole thing, or you just work on the numerator. And the numerator is where we find f of x plus h minus the f of x. We're taking the difference of the y values, correct? All right, so if I want to put that over h, kind of combine it into one step, that's okay. All right, I need the y value of this big whopper over here. So I'm going to write down negative 3x squared minus 6hx minus 3h squared plus 5x plus 5h minus 6. If you want to put it in parentheses, you can, but since that kind of confused some of you a little bit ago, I won't put it in parentheses. But now I need to put what? Minus, do I need a parentheses for this next part? Yes, I do. So in parentheses, I put the y value from the original ordered pair, and that's going to be a negative 3x squared plus 5x minus 6. Wow, that takes a lot of room. And all of that is over h. Okay. What next? Correct. We're going to have to distribute through so we can clean up this numerator. So my f of x plus h minus f of x is now negative 3x squared minus 6hx minus 3h squared plus 5x plus 5h minus 6. Tell me what to write next. Plus 3x squared. And then a plus 6, right? All of that over h. Woo. Okay. Anything cancel? This will tell us if we've done this right. What do you notice? Okay, if I look right here, there's a negative 3x squared and a positive 3x squared. They're gone. This guy has an h, and I don't see anything that looks just like it, so I leave it alone. This guy has an h squared, and I don't see anything like that, so I'm going to leave it alone. But do I see something this 5x can combine with? The negative 5x. And the negative 6 plus 6 cancels out. Are the only terms left ones that have h? Yes. So here's where we are. Huh? I know. I guess I'm a math nerd. I get so excited about the silliest little thing. Well, it's silly. It's really cool. It makes me feel good when I know, okay, I found it. So I'm finding the limit. As h approaches 0 of, I'm only going to write down the terms I didn't mark out on top. So I have negative 6hx minus 3h squared plus 5h. That's all of them, isn't it? Over h. Okay, so what happens now? And in order to be able to cancel out h's, what will I need to do in the numerator? I got to factor out an h. So now notice this is where limit showed up, because we finally have something that will be our derivative function that we're trying to evaluate. I have not yet plugged in, so don't drop limit. That's going to be equal to the limit as h approaches 0 of, now if I factor h out in the numerator, tell me what would be left in parentheses. Negative 6x, what would be here? Well, wouldn't it be minus 3h, because the h times the h is where the h squared comes from, plus 5 over h on bottom, right? All right, give me a quick signal. Are we here, here, or here? How are we doing? All right, we're working on it. The more you practice, the better you get. Now, why did I want to factor out the h? So I can do what? Cancel out with the h on bottom. So these cancel out. And now, since it's not a fraction, can I directly sub in 0 for h? Remember, that was my whole problem. If I had an h in the denominator, I couldn't sub in because it would give me something that's undefined. It would give me a 0 in the denominator. So now I'm ready to sub in, and that means that I will find this limit by putting 0 in for h, and I'm going to get negative 6x, because there's no h there, so that term just stays like it is. What happens if I put in 0 for h here? It's going to become a 0, and then that's just plus 5, so it's just going to stay plus 5. Did I write something down wrong? Oh, sorry. Let's fix that. Okay. And that means if that cleans up, we just have negative 6x plus 5. That is going to be what f prime of x equals. And that would mean I could go to any point on that original function, which we knew was a parabola, and if I wanted to find that instantaneous rate of change, what's the slope at that one point, all I would have to do is plug in the x value at that one point, and I would know what the slope is, which would mean if I drew that tangent line, remember we can draw a line that shares that same point, it's going to be the same slope as what you would have on that tangent line. That'll be the slope for that point of your curve. And this way, I've got a formula that I can use for any point on the curve. I won't have to go through using 2 different points and just calculating this by hand over and over and over. Make sense? All right. There is a lot of power in calculus. Yes, sir? Oh, you're so right. Thank you. Let's back up and do that. I'm glad you pointed that out. That on this top one, what would f prime of 1 be? It's still going to be 7. It doesn't matter which point I pick. Remember, these were all going to have a slope of 7. I think we said it. I just didn't write it down. So now this is going to show us we're going to get some different values on this one because we still have an x in our derivative function. So let's do that down here. And if this is what the function is to find the derivative, or to find the rate of change, then let's see what f prime of 1 is. All I have to do is plug in 1 for x. If you clean that up, what do you get? 1. Yeah, negative 6 plus 5 is a negative 1. So this is telling me if I wanted to know what the rate of change or the slope is when x is 1 on the original curve, the slope would be negative 1. All right, I want to show you this just so you can kind of get an idea. All right, let me go into the y equals, and I'm going to type in negative 3x squared plus 5x minus 6 because that's our original function. And I want to, let's do this. Well, we'll start here. We'll just start with the standard graph. All right, so look at this thing. It's a parabola. Did it surprise you that it opens down? Let's just check and see what you remember about functions. You remember what this thing was? It was negative 3x squared plus 5x minus 6. Should you have expected that it opens down? And the reason is There's a negative in front of the x squared. Good. That's what told me the parabola was going to open down. So I'm supposed to be finding the slope when x is -1. Now, let me zoom in a little bit. Okay. And here's where x is -1. Actually, I got 2 zoomed in because that is not showing me enough y values. I want my y's to go to, let's say, something like -5. Okay, so now we'll graph. Oh, still not enough. Okay. So let me go to the window. We'll make it -10. How about that? Okay, so when x is -1, we've got a point that's something like this, right? Okay, and so what I'm looking for would be when x is +1. What I'm looking for is what the slope would be. So when x is +1, I'm right in here, right? And wouldn't this be, if I just tried to draw a line that touches that point, wouldn't it have to have a negative slope? Yeah, and that's telling me it's going to have a slope of -1. Now, if I were to plug in 2, f prime of 2, that's -6 times 2 plus 5. How much is that one? That's a -7. All right, if I get all the way over to -2, that's going to be like here. Does that look like that's a very negative slope? That'd be a much steeper line than we would have here, okay? And then if we were to put in 3, it's going to be even more steep. And -18 plus 5 is a -13, okay? So that's how it relates. We can pick any point we wanted to on this curve. We could put in negative values and see what the slope would be on the negative side. You can decide whatever you want to test, okay? So that's how you use the definition for derivative. That's what that was, is the idea that if you pick any 2 arbitrary points on your graph and you find the limit as the distance between them approaches 0, that's how you're going to end up with finding the instantaneous slope, okay? And I promise you're going to need to practice more and you get better at it. Yes, ma'am?
So your answer can either be equation or
Yes. Now, when do you think your answer would be a number? When it was a linear function to begin with, because the rate of change is constant everywhere on a line. The slope never changes. But if you have something that's not linear, so if it's, and most of the time what you're going to see will be something that's polynomial. So maybe it's going to start off as an x squared or an x cubed or something like that. Then you will get a formula for derivative that would still have a variable in it, because you're going to have a changing rate of change depending on where you are on the function, because there's curves. Okay? Now, this gives us a little bit of an idea of how this could apply in business. So it says the profit and hundreds of dollars from the sale of X items is given by this function. So if you're a business person, that's going to be one of the things you're going to want to track. Will be how am I doing? You know, if I got profit that's increasing, or is my profit decreasing? So this is your function to find profit. Now, you want to get the average rate of change of profit from selling 2 items to 4 items. And that might be important when you want to know, am I actually earning more profit as I'm selling more? Or am I not? I mean, if that's the case, then you got to figure out, what do I need to change? Because obviously I don't want to do more work and sell more items and not earn more profit. You know what I'm saying? So how could we find the average rate of change if I have this X value and this X value? Is that enough information for me to just go in and get average rate of change? Absolutely. That's what a derivative is. It's just as we take the limit, as h approaches 0, it gives us the instantaneous rate of change. Average just means I need 2 points. So for part A, all I need to do is take the y value when I'm using 4, subtract the y value when I'm using 2, and divide it by what? That's my difference in the y values, divided by 4 minus 2, the difference in the x's, right? Because these are 2 specific points. Now, here's my function for my p of x. Do I need to know what I get when I plug in 4 in this function? Okay, have you got your calculators? Can you do that? I want you to be able to tell me what that number will be. So here's what you guys just told me. You plugged in 4 to the original function, and that gave you a value of 18. You plugged in 2 for x, cleaned that up, you got a value of 4. Now I think we can do 4 minus 2 without the calculator. That's how much? 2. So I have 18 minus 4 is 14 divided by 2, which is 7. So what I have found is the average rate of change of profit from 2 items to 4 items. Now, here's what I'm noticing. Is this number positive or is it negative? If I'm talking about a change in my profit, is a positive number a good sign? Yes, if it had been a negative number, that would have told me my profit went down. This is telling me my profit's going up. Okay, so that's good. Now, B. Can you get the instantaneous rate of change equation, which is also called what? Starts with a D. Derivative for this using the 4-step procedure. And I think you can say, yes, I can, right? Let's see if you remember. How many points will we need? What do we use here? How many points? 2 points. The difference is the first point will be x comma what? This up here, 2x squared minus 5x plus 6. What will I need to use for the second point? The x value needs to be x plus h, right? And now to get the f of x plus h, I'm going to have to do a little bit of work by plugging x plus h in for x to the original function. So that means I'm going to have 2 times x plus h in parentheses squared minus 5 times x plus h plus 6, okay? And we just squared x plus h a minute ago. You want to reuse what we found so we don't have to draw another table or use FOIL again? I believe it was what? X squared plus 2. And it doesn't matter if you put hx or xh. Either way is fine. I'll put xh this time. And then h squared. Those were the terms we got when we squared that. All right, distribute here, and you get? Well, let's go ahead and finish out the end of this. If I distribute the minus 5, I get minus 5h, and then a plus 6 on the end. Now we'll distribute this 2 through here, and we get 2x squared plus 4xh plus 2h squared, and then we have the minus 5x minus 5h plus 6. Whew, let me pull that up so you guys can see it. And that's the totally cleaned up, all the terms we need for the y value of the second point, right? So I'm going to write all that right here. 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 6. Can't be afraid to cut down trees and find derivatives. Okay? What am I going to do next? Let's see if you remember. So I found my 2 points. Now what? I'm ready to go that little formula, right? The f of x plus h minus f of x. All right, so we're going to have f of x plus h minus f of x on top over what goes on bottom? H. Hope you guys don't mind. I'm kind of combining those two steps in the middle. I think it's easy enough to do that. Now I got to make sure I copy everything down correctly. Pay close attention to signs. So I'm going to have 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 6. That's everything from this y value. What do you write now? Minus parentheses. Good. 2x squared minus 5x plus 6. I'm going to close that parentheses, and then all of it goes over h. Okay, you guys clean this thing up. So you guys were able to distribute this minus sign through. I'm just going to do it this way. Make that a negative, make that a plus, make that a negative, and these canceled, and these canceled, and these canceled, and what I have left now will be this 4xh plus 2h squared minus 5h, that's the only terms I didn't mark out, over h, and I'm ready to do what with it? Find the limit as h approaches what? 0. Good. And so to do that, you're right, we got to factor out the h on top. Do I need to write limit? Yes, I do. So limit as h approaches 0 up. When I factor out the h on top, what will I have? H onto 4x plus 2h minus 5. My h's cancel. Am I ready to sub in now? Because I can put the 0 in for h, and I will actually get an expression that is not undefined. So when I do that, I come up with my f prime of x equals what? 4x minus 5. Because when I put in 0 for this, that's going to become 0, isn't it? 2 times 0 is 0. So here is my instantaneous rate of change equation, or my derivative. Now, last part says, using the equation found in part B, what we just found, find the instantaneous rate of change when x equals 2, and then we want to interpret the results. So that means let's find f prime of 2. So what am I going to plug 2 into? This. The f of x or the f prime of x? I better plug into the f prime of x, right? Okay, because this is going to give me my instantaneous rate of change. If I plug into the original, what's that actually going to tell me? Remember, x stands for how many items I've sold. So if I plug 2 into this one, it would tell me when I sell 2 items, this would let me know how much profit I would make. Okay, what I'm finding here is if I sell 2 items, what is the change in profit? Okay, so I can tell if my profit is increasing or decreasing. So I'm going to plug in 2, and what's that going to give me? That's going to give me the number 3. Now, here's what I would do to interpret what this means. If I go back and I read this again, it says the profit in hundreds of dollars. Okay, now that's important because it's not $3, it's how much, 300, that we just discovered. Now, what is that actually telling me? Here's what it means. When the second item is sold, because what I'm finding is at the instant I sell the second item, the profit is increasing by $300. Okay? Now, if I wanted to know what the change in profit is when I sell 3 items, I could do that. I could plug in 3 and I could see if my rate of profit is continuing to increase or if it's starting to decrease. From a business perspective, think about it. What are some of the things that affect your profit? I mean, you've got things you have to pay for if you run a business. So let's say you make chips, okay? So you're making tortilla chips in your company. Tell me what kinds of expenses you know you're going to have to spend money on to make a bag of chips. All right, you got ingredients. You got what else? You got rent or some kind of building expense. You got, yeah, employees. You've got utilities. So let's say, you know, you've got your 10 employees. You've got your equipment costs, your rent. Some things stay the same. They don't change. But other things will change because if right now, let's say you make 100 bags of chips a day, you're going to have a certain number of ingredients you have to buy to make 100 chips. What if you want to increase production? What's that going to do to the expense of materials? They're going to get increased. And depending on the workload, which you maybe have to add more employees. So if you end up not hiring more employees and you have to pay overtime, and you've got the extra ingredient cost, you might discover that by actually making more bags of chips and selling them, my profit is starting to go down because I'm having to spend too much extra money on other things. You see what I'm saying? So it's always a changing scenario in the business world, and that's why you need to have the tools to analyze whether you're going in the right direction or not. Because if you find something's not working there, then that's when you may need to take a step back and figure out, okay, what can I change to help increase my profits? All right. So let me